Right, folks, question 5. Okay. Can I move this image? Oh yes, I can. Wow. Okay. Look at this free body diagram. Very amazing. Let's just jump straight. Replace the three forces with an equivalent force couple pair at B. I think at first glance, it's quite easy to identify which forces becomes a couple, but it's okay. I can explain. What is a couple? Couple is basically when two forces act in a total opposite direction of each other, but they are of the same magnitude. Okay? These two forces can then become a couple. And this is their special property. In terms of resultant force, it's going to be 0. Okay? It's going to be 0. But the moment is going to be, let's just take this as d divided by 2, d divided by 2. The moments, if you think about it, is really just 50 times d divided by 2 plus 50 times d divided by 2, which give me 2 times of 50 d divided by 2, which is essentially just 50 times d, which is why the moments of a couple is always force times d. This is one way to understand why this is the equation such. So yeah, so now that you understand the idea of couple, the principle of it, the formula, so we can now identify which one is our couple, which is very simple, which is the 90 newtons forces that is going to be our couple. So I'm just going to put there C, C. So these two are going to be our couple. And because they are pointing in this direction like this, is going in a anti-clockwise. Clockwise. And for this module, okay, if you were to point your thumb downwards, you do the right hand rule thing, whatever. Clockwise moments are basically negative moments. Or the polarity is negative, okay? Right, so now that we have removed this 90 newtons to become a couple, let's just find the resultant force. We'll come back to the couple later. So the resultant force is fairly simple. You're only left with that one red arrow that is we haven't touched yet. And if you haven't already noticed, it's basically 216 newtons. Okay, 216 newtons. But of course, resultant force, we have to identify where is the resultant force pointing at. In this case, basically the direction. I know it wasn't like brought up in a tutorial, but in a lecture it was. The reason why we have this whole ass vector thing. Vector have both magnitude and direction. In this case, the 216, we have identified the magnitude, which is basically 216. Now we need to identify the direction. And in order to identify the direction, we have to basically identify it with reference to absolute x-axis. Not bar AB being the axis, but like on paper right now, if I were to look at it, my x-axis will be one straight line like this, okay? So we need to identify the angle. So it's basically, what is this angle over here? So let's just do some simple math. Or not say simple, but drawing, I guess. We can now make this a right angle. So this is essentially my y-axis. This is basically, what are you, mate? Oh wait, hold on, let me just draw this line out also. Okay, so now I can identify that this angle is 90 minus 55, because here forms a right angle. Okay, so 90 minus 55 gives me 35. Then I also know that bar ABC is being tilted at a 30-degree angle. So if I, so 30-degree angle, right? And then this bar is going, this blue line is also going parallel to ABC. And then this black line over, this line over here is parallel to our x-axis. So I can safely assume that this is 30 degrees. Okay, I hope I made myself clear there. Oh, there you go. I have found my degree, the angle of the 216 with reference to absolute x-axis, which is basically 30 plus 35, 65. And thus I got my first half of the answer. Now let's find moments. I think at this point it is quite clear cut that our moment will be pivoting about point B. So let's just go ahead and do point B. Moment about point B equals to moment of couple plus. Okay, I'm just going to assume that my life is very happy, so positive. Okay, so moment from the 216 is positive. That's why I put this plus. It can be minus, it can be plus, I don't know. No one knows. My couple may not even be positive or not, whatever. But I'm just going to put both as positive. Then, oh, sorry. We're not finding equilibrium. We're finding moments. So, moments about B equals 2. Couple. So couple is what? 90 times D, right? D is basically the distance between both couples. In this case, it's 600 plus 450 mm, which is essentially just 1.05 meters. Okay? You can leave it in mm, no one's stopping you, but just remember your unit will be Newton times mm, not Newton times meter for your moments. Okay, then plus. Oh damn, I actually do need to consider polarity already. Alright, my bad, guys. Alright, let's consider polarity now. So for my 90, for my couple, we are going in a, we identify over here already, we are going in a clockwise direction, so it is a negative. Meanwhile, our 260, well, if we were to draw the lines, is basically here. I mean, it's exerting force in this side, perpendicular and parallel. In this case, it's going this side, which is anti-clockwise, which is positive. So we can keep this plus sign. So moment about the 260 is positive. So 216 times. What's the distance? Remember, we are finding perpendicular distance. So in this case, perpendicular is from B to C. In this case, 0.45. Type that into the calculator. I'm also going to type that in because I also want to be sure of my working. Hold on. Oh, bing, bing, bing. Mistake number 1. It's not 90. It's 90 cosine 20. All right. Thank you guys for keeping a lookout for me. Okay, now I feel dumb. Oh my god, another one. It is 216 cosine 55. Guys, I feel so stupid now. And there you have it. It gives me moment of... Okay, I'm just going to type in whatever that's on my calculator right now, which is basically negative 33.05 Newton meters. 4SF, cause I'm weird. But that's okay. It's basically just the negative, just saying my polarity is wrong. Okay, so in this case, it's basically 33.0 Newton meter in the in the clockwise direction. I think. I hope. I guess. Yep. So now, part B. Determine the single force that is equivalent to the force coupled system obtained in A, and specify the point of application on level. What are these means? This basically means that I'm just gonna yeet. Whoa, so clean. Okay. So we have identified that the resultant force is basically 216 from 65 angle from absolute x-axis. So in order to give me moment 33.0, where can I place this force to give me this moment on bar ABC? So essentially what the question is asking is, I just want to copy and paste the exact same magnitude and direction of this force. I'm going to place it on this bar here. I can place it on this bar here. I can place it anywhere. But where can I place it so that the distance from the force to the pivoting point gives me moments of a 33 value? Very simple. You have the force, you have moments, you don't have distance. And this is where you find your distance. So distance is basically 33 divided by your 216. I believe in this case, we shouldn't use 65, but we should use 55. Because now our x-axis is along ABC. However, your force should still be with reference to absolute x, okay? So basically, this line, what's a good one? Great one. This line should be parallel to this line, parallel to this line, parallel to this line. All these lines should be parallel to each other, okay? So we now take 33 divided by 216 cosine 55. What do you get? Whoa, you get 0.26636 meters, which is 266 mm. Okay, I mean, let's be real. The application is there, okay? Just maybe the numbers are not that clean. Okay, but there you have it, your part B. I really hope I'm clear enough. If I'm not clear enough, please tell me. I can always redo. I'm being serious.